For many of the data engineers, ETL has been the backbone of data engineers for decades. You extract the data, transform it, and load it. We have built pipelines, batch jobs, and data warehouses. But what I've seen is that data engineering is just about moving data anymore. We are being asked to deliver data faster, more reliable, and at bigger scales, and smarter too. It's not enough to simply pipeline data into a warehouse and call it a day. What's happening now is AI and machine learning are no longer just downstream consumers of data. They are moving upstream into our engineering process itself. AI is becoming embedded inside our pipelines, detecting anomalies, generating transformation logic, autoscaling infrastructure, and automating the data quality checks. Suddenly, we weren't spending days combining through bad data. We are getting real-time alerts with anomaly explanations. That freed us up to focus on deeper improvements rather than constantly firefighting data errors. Before we go deeper into this topic, let me quickly introduce myself and why this journey into AI-powered data engineering has been so meaningful for me. I am Janardhan, and I've been working as a lead data engineer and solutions architect for over a decade with hands-on experience building and modernizing data platforms at organizations like Capital One, FINRA, and FMCSA. It is an entity of our DOT, Department of Transportation. At Capital One, I was part of a major modernization effort moving away from legacy mainframe systems to microservice-based cloud platform to support credit card applications like acquisitions, approvals, and risk decisions. This gave me first-hand exposure to transforming complex nested Avro data into clean, analytic, ready data marts while having to deal with the schema drift, real-time data ingestion, and the data quality at scale. And at FINRA, I have worked with one of the largest data pipelines I've ever seen, ingesting over 250 billion daily trade events across the US stock market. We weren't just processing huge volumes of data. We had strict regulatory timelines and needed zero data loss, high accuracy, and fast availability. That's where I saw AI and automation set up in not just as an add-on for analysis, but as a core part of the engineering process, helping us monitor data quality, detect anomalies in ingestion, and auto-tune processing pipelines. And most recently at DOT, FMCSA, I led data initiative focused on safety and compliance reporting for commercial motor carriers. And when you are supporting public safety decisions, you can't afford manual errors or delay in the data pipeline. Like here, we had to deliver inspection and violation reports for all 50 states based on millions of records per month from various inspection systems. We implemented tools like PyDQ for automated data quality checks and even explored using ML models to flag suspicious inspection records in real time. What I've learned across these roles is that data engineering is no longer just about pipelines and warehouses. It's about reliability, scalability, and increasingly about intelligence. Let's talk about the reality of data engineering today and why AI has become such a critical piece of the conversation. When I first saw these numbers, they really hit home. 68% of an engineer's time is spent on maintenance rather than innovation, and 4.5 hours a day is spent on debugging and fixing pipeline issues. And 23% of data quality problems aren't discovered until they are already in production. Honestly, that feels about right because I've been in those trenches. A lot of time wasn't spent building new features or optimizing for business outcomes. It was spent answering questions like, why did this pipeline fail last night? Is this a schema issue or a data quality issue? Did something happen upstream, change that no one told us about? And when pipeline breaks, the pressure builds fast. For decades, ETL has followed a very traditional, very rule-based model. You extract the data from source systems, you map it into a target schema, you transform it with predefined rules, and then load it into a data warehouse. Sounds simple enough until you are dealing with hundreds of source systems, constantly evolving schema, dirty data, and complex transformation logic. Here is what the traditional ETL world looks like. Time-consuming manual mapping between complex data schemes, a very rigid rule-based transformation that struggles to adapt to change, like transformation that are hard-coded logic, or predefined logic. If X is Y, if X, then Y, else is Z. But what happens when upstream data changes? No new columns, different formats. These rigid rules break and require manual interventions to patch them. And reactive error handling. In traditional world, you don't find out about errors until they have been already broken your pipeline or corrupted your downstream data. Either way, you are reacting after the damage is done. Static performance tuning. And let's not forget the hours spent manually tuning Spark configuration or query parameters to try and optimize runtime for a specific dataset or a workload. Once tuned, it's static. Now compare that with the AI-powered ETL approach. Automatic schema discovery and intelligent hands-free mapping. Instead of developers manually mapping every field, AI algorithms can scan source data, infer data types, and recommend or auto-map fields to the target schema, even for complex nested JSON or evolving source schemas. Adaptive transformation powered by machine learning. Rather than static rules, AI models can learn transformation patterns from the data. Proactive error detection and resolution. AI doesn't wait until the pipeline fails at runtime. It proactively analyzes incoming data before execution, predicts potential errors, and can either auto-resolve or flag issues. It's a shift from reactive to predictive pipeline management. Self-optimizing real-time execution, and perhaps most exciting, AI can monitor job execution in real time, automatically tuning configurations like partitioning, parallelism, memory allocation based on current workload and resource conditions. So you are always operating near peak efficiency without manual tuning. So beyond just technical improvements, let's talk about the strategic impact AI brings to ETL and data engineering overall. First, self-optimizing real-time execution means our pipelines adjust on the fly, whether it's handling sudden data volume spikes or adapting to infrastructure bottlenecks. No more endless manual tuning or constant babysitting. But more importantly, it redirects engineering effect. Instead of spending our days fixing failed jobs or remapping schemas, engineers can focus on innovation, new features, and high-value work. And the numbers speak for themselves. 85% reduction in manual schema mapping, which speeds up project timelines dramatically. 92% of data anomalies are intercepted proactively before they ever reach production reports. And 43% reduction in pipeline maintenance cost, freeing up both budget and bandwidth. When I think about my experience at Capital One, where even small data errors could ripple into compliance risk, having AI proactively catch issues before they surface isn't just a time saver, it's a risk reducer. This isn't just about automation, it's about elevating the entire role of data engineering into a more strategic, proactive function. First, AWS Glue, a serverless ETL platform that uses machine learning to automatically detect data schemas and generate mappings. This drastically reduces the need for manual coding, accelerating the time it takes to integrate and prepare data. Next, Databricks Autoloader, which brings intelligent data ingestion with built-in schema evaluation handling. This tool ensures that changing data structure doesn't break your pipelines by dynamically adjusting to new fields or formats as they arrive. And finally, anomaly detection system. These leverage machine learning to continuously scan data flows for unusual patterns. They proactively identify anomalies and potential issues before they impact business decisions or downstream systems. If you look at the chart, you will see dramatic improvements across 4 key areas. Query creation time was cut by more than half. Debugging time dropped from nearly 90 minutes to about 30 minutes. Error rates also reduced significantly, and performance tuning time was slashed from 2 hours to under an hour. Overall, the firms are seeing 64% productivity increase. This demonstrates how AI not only speeds up routine tasks, but also improves accuracy and performance in SQL development workflows or the transformation development workflows. This slide shows how AI is transforming pipeline maintenance with self-healing data pipelines. It starts by automatically detecting anomalies. Machine learning models flag unusual data patterns before they snowball into bigger issues. Then the system moves to diagnose the issue using root cause analysis to classify what went wrong. Once the cause is identified, it moves into the apply fix stage, pulling an automated correction from a pre-built library of solution, no manual intervention required. Finally, it enters a learn and improve phase where the solution is recorded, so the system keeps getting smarter and faster at fixing similar issues in the future. This closed loop approach reduces downtime, boosts reliability, and shifts engineers away from firefighting towards strategic work. We are looking at quality validation frameworks, which are critical for maintaining trust in the data pipelines, especially as we scale with AI. It starts with defining expectations, setting rules either based on domain expertise or even automatically discovering patterns from the data itself. Then we test continuously, not just at the end, but validating data at every stage, like ingestion, transformation, and pre-publishing. If something fails those checks, we don't have to jump in manually. Instead, an auto-remediate layer kicks in, applying machine learning recommended fixes for common issues. And finally, we monitor metrics over time to track both data quality scores and how effective our fixes really are. This process shifts us from reactive firefighting to proactive continuous data quality assurance, something that's incredibly valued in high stakes environment like a finance or the government. Let's talk about where we are and where we are heading. This slide lays out an industry adoption timeline for AI-powered data engineering. In 2023 to 24, we have seen AI SQL assistants and automated schema inference becoming mainstream tools in many organizations. Moving into 24 and 25, we're on track for self-healing pipelines, automated anomaly detection and correction, reaching about 60% enterprise adoption. By 25 and 26, the industry shifts towards self-optimizing systems where infrastructure dynamically scales and allocate resources based on business priorities. And looking ahead into 26 and 27, the big milestone is fully autonomous data platform systems that monitor, optimize, and remediate with minimal human oversight. The key takeaway, the AI in data engineering isn't theoretical anymore. It's a fast-moving wave that's fundamentally changing how we design, operate, and scale data platforms. Now that we have seen the potential of AI in data engineering, let's talk about how to actually implement it in a structured way. This framework has 4 key steps. First, assess opportunities. Look for the repetitive high-effort tasks in your workflows. This could be manual schema mapping, tedious data validation, or repetitive debugging. Next, start small. Don't try to automate everything at once. Pick one critical pipeline or the process and test AI automation there. Third, measure impact, track time saved, improvements in data quality, and even team satisfaction to prove the value. And finally, once you have shown success, scale gradually. Expand what worked to more pipelines and parts of your data platform. Retrospect your previous experience from existing pipelines. This approach helps reduce risk while ensuring adoption is sustainable and measurable. The key takeaways of this presentation, the first one is AI is transforming ETL from manual to autonomous. We are seeing up to 85% reduction in schema mapping effort and 43% cut in maintenance cost. Second, a self-healing pipelines proactively catch 92% of anomalies before they cause downstream issues. That's a huge boost in data quality and trust. Third, start small but start today. Pick one high-effort, repetitive process to automate for quick wins and momentum. And finally, free your team for strategic work. Every hour saved on maintenance is an hour unlocked for innovation and business value. Thank you so much. Excited to see how we all move forward in this AI-driven future of data engineering. Thank you so much.